Hello, everyone, and welcome. Before we kick things off today, I would like to just ask that everyone refrain from recording any audio or video or taking any screenshots during today's webinar. This presentation and the corresponding slides are copyrighted by Robson Forensic and may not be recorded, copied, distributed, or otherwise used without authorization. Today's presentation is from one of my colleagues, Kevin Gorman. He'll be talking about roadway features that can kill motorcyclists. If you have any questions as we go through the presentation, you can submit them to us through the Q&A button at the bottom of your Zoom window, or you can email them to us at inquiries@robsonforensic.com. With that, I will hand it over to Kevin.
Great, thanks, Ann. And good afternoon, everybody. As Ann said, my name's Kevin Gorman. I'm a civil engineer here at Robson Forensic. I have over 17 years of Department of Transportation, heavy highway construction and construction inspection experience. And I also have the unique combination of background that I have 10 years in law enforcement, where I was a certified accident reconstructionist and performed accident as well as criminal investigations. I've been a licensed motorcycle operator since 1992. And also received training as a bicyclist cop while I was with the city of Harrisburg. My forensic specialties that I typically get involved with are temporary traffic control and how it was employed on construction sites, and then highway construction standards of care, how projects were completed, contract compliance, and issues like that. What I'd like to discuss today primarily is roadway defects that are created during construction. These defects nowadays are inherent to the construction process, mainly because we try to do phased construction. In other words, we try to inconvenience traffic as least amount of time as possible. So we don't just shut down the whole roadway, do all the repairs, and then open it back up. We have what's called phased construction. So that phased construction ends up leading to areas that are not quite ready for traffic, but can be opened up to traffic, and it might be different than adjacent areas. And these are hazards. As you can see in this picture, that's a hazardous condition. And the goal of temporary traffic control and mitigation is to make these hazards reasonable during construction. And we need to make sure that they have proper warnings and guarding when required, and ultimately that they comply with the applicable standards. And a failure to properly mitigate these hazards can create a condition that we consider unreasonably dangerous, which could then lead to damages or injuries. Two-wheeled vehicles, and especially motorcycles and bicyclists, are especially vulnerable to these roadway defects just by the nature of how they move and how they turn, and the relationship of the center of gravity and opposing forces of gravity and roadway friction, and any variances to this equilibrium for a motorcyclist or bicyclist can throw that balance off and lead to a loss of control, which is what we typically see where motorcyclists and their bicycles encounter some deviation or defect in the roadway. Vehicles generally with four wheels can overcome obstacles as 2 to 3 inches in height, but we found that motorcyclists and bicyclists have difficulty crossing these differentials that are as little as an inch in height. These abrupt changes in heights with vertical lips are challenging for motorcyclists to traverse and can lead to a loss of control. So the roadway defects that I'm going to talk about today are primarily divided into 4 categories. I'm going to discuss these 4 categories. I'm going to discuss why they're hazardous, the steps that should be done to provide reasonable protection to motorists, in other words, steps to mitigate these hazards, what makes them unreasonably dangerous, and some of the common case issues that we see related to these specific defects. So the first one we see, I'm going to talk about are uneven lanes. And these are height differentials or drop-offs that run longitudinally with traffic. As you can see in the photo to the left, there's a height differential between the far left lane and then the lane to the right of that in this case are separated by construction grounds. These drop-offs can occur between adjacent travelways. They can occur between a travelway and a paved shoulder. They can occur between a travel lane and an unpaved area off to the side of the roadway. And these are created by partial width milling, partial width paving overlays, and roadway widening, where you're looking to build a section of roadway or an area of travel lanes or outside the area that they had previously existed. So why are these longitudinal drop-offs hazardous? Many times motorists are allowed to cross them. They will open them up, open a 2-lane highway, and there will be a longitudinal height differential between traffic, and traffic is not prevented to cross them. And these height differentials can be difficult to see. It may be night. A lot of times the pavement color is the same. You know, a new black overlay on the left, a new black overlay on the right, and a motorist may not be able to estimate the height of that differential, and thus may not be able to anticipate the impact that that height will have on their stability and ability to cross it. These differentials can lead to a loss of control of a vehicle, and as we discussed, motorcyclists are very more susceptible to this loss of control by trying to cross a transverse edge or a longitudinal edge. And then ultimately a loss of control can lead to not only the bike going down, but then impacts with fixed objects, whether it's side of the road, whether it's vehicles going the same direction, or, you know, bad case scenario, vehicles in the opposite direction. Case issues that we see involving longitudinal drop-offs or edge differentials are contractors failing to know what the height is that they actually created during construction. States have specifications that limit the height that can be exposed, or that traffic can be exposed to. And if contractors don't know the height they're creating, or if their construction processes are not controlled enough that they don't know the height, then they may not realize that they should have mitigated that height, or maybe even guarded that condition for traffic in the first place. We see a failure of contractors using appropriate and proper temporary traffic control, such as warning signs. And the purpose of these warning signs is to give advance warning, as well as warning throughout the condition that, hey, motorist, you're about to encounter a differential here, a height change, and be ready for it. Maybe move to a lane ahead of time and not have to cross it, or at least prepare yourself mentally that there may be an effect on the handling of your motorcycle as you're traveling through the work zone. We see a failure to apply appropriate edge treatments, and this kind of ties in with number one, where if they don't know the height and they exceed the allowable height, there may be a mitigation that was required of them, and this mitigation was not performed, such as tapers or again, preventing traffic from crossing over these edge differentials. And the last one is that basically guarding the public when conditions exceed an allowable height, and preventing traffic from crossing that condition. Maryland, for example, recognizes that these height differentials are a hazard for motorcyclists, and many times, as you can see in the signs to the right, they have placards specifically identifying motorcyclists and advising motorcyclists to stay in a single lane, which would prevent a motorcyclist from crossing over this height differential, which again, as we've discussed, is especially hazardous for them. So a vertical drop-off basically creates a substantial number of crashes each year. AASHTO has generally suggested that no drop-off greater than 2 inches exists between travel lanes, but DOT standards vary across the country, and where they establish their own levels that they feel is reasonable for highway work on their projects. And these height differentials can vary based on the type of edge that you end up creating. For example, a vertical edge, which is created by a milling process, which is a very sharp and pointed edge, TxDOT, for example, limits that height to 1.25 inches. But if you had an overlay, which is a softer height differential, because you don't quite have that sharpness of freshly cut pavement, TxDOT can allow up to 2 inches for an overlay between lanes. The standard of care is to know what the maximum allowable height differential is, and to comply with the requirements based on the height differential you get. You need to identify the proper edge treatment for that differential. You know, is it putting a taper? Is it blocking traffic? And again, as I discussed, these may differ between milled edges and pavement overlays. The temporary traffic control that we see for this are uneven lane signs, like you see there in the upper left. And then we also see lane closures that have proper delineation, like a prior picture that had barrels along there, which would have prevented traffic from crossing over the lanes. Sometimes we see solid white lane lines prohibiting traffic from crossing height differentials, and there may be signs coming into the zone that says stay in your lane, or, no passing. So the second hazard that we see developed in construction sites are bumps, and bumps are kind of a smaller version of a height differential. They exist at utilities. Many times they run transverse traffic. In other words, as opposed to the longitudinal one where traffic runs parallel with it, traffic runs perpendicular to these bumps. These can be created at the beginning of a milled section or an overlay section where traffic is dropping into the newly milled area, and then they would occur at the back end of that milled section where traffic has to bump up and come out of a milled area. These can be created by roadway plates, which have some inherent hazards for themselves. These can be transitions to or from temporary roadways where maybe bypasses are being constructed and traffic is being moved off the main line onto these bypasses. And as we see in the picture to the left, many times these are created by utility infrastructure, such as manholes or valve boxes and inlets. Wire bumps hazardous. If not properly warned of, they could be an unexpected transition. And again, motorcyclists and bicyclists are especially vulnerable to these unexpected transition or unexpected changes in their driving. Steel plates offer an additional hazard of being slippery. If they're not properly treated on the surface, and especially when wet, they have a significantly lower level of friction that can lead to losses of control for vehicles. I worked on a case where a motorcycle police officer was crossing one of these plates, and it was wet, it was improperly treated, and the bike slid out from underneath them. These steel plates can also be across pedestrian paths, and if they're not treated properly, can lead to a slip and fall for pedestrians, just due to the steel surface getting wet. Case issues we deal with bumps are failure to use proper tapers. If you remember on the previous screen, there was a rubber ring around the manhole that created a taper to gently and gradually get up over the lip of the manhole. In the photo to the right there, you see an asphalt, we call it an asphalt taper, basically around the perimeter of those steel plates, and that creates a taper to soften and lessen the vertical rise that the vehicle sees at that instant. We see inadequate temporary traffic control, and you'll see this as a consistent case issue we see for our temporary traffic control cases, where they don't have steel plate ahead signs, they don't have warnings to give motorists notice of the hazard and allow motorists to react properly. We see a failure to properly texture or mark steel plates, and a failure to secure plates. Plates being loose or bouncing around could either come loose and break free of their taper, or actually become loose enough where they slide out and can create an issue for vehicles or pedestrians. So what is the standard of care for bumps? Basically, the biggest thing is to identify the height of the bump and what's the required taper for that. New York, for example, identifies or adjusts the amount of taper that they like based on not only the duration for which that taper is in place, but also the speed limit of the roadway in which that taper is needed. Highways, for example, require a longer taper, which is a smoother transition, and a slower speed roadway, New York identifies a shorter one. And then as you get into longer durations, that's something tapers in place in New York. They further extend the length of the tapers for high-speed roadways. New Jersey and Illinois, for example, require 20-to-1 for their tapers, regardless of the duration or the speed limit of the road. The temporary traffic control, again, a consistent message here is that bump signs are placed in advance of these. We see steel plates, signs being placed in advance of the steel plates, pedestrian warnings, or even pedestrian detours, guiding pedestrians around the steel plate if it can't be done properly, or if being directed across the steel plate, that there's proper warning in place there. And then having a proper taper, in other words, a proper lead-in to reduce that height differential to a manageable driving surface for vehicles. The third hazard is part of a roadway rehabilitation process. Chip seal is one word for it. We've seen them called tar and chip, slurry seal, cape seal. They're all terminology for generally the same process, and that process involves laying down a layer of asphalt binder and then coming through and laying a loose layer of stone on top of that glue, let's call it, and then rolling and compacting that stone into maximize adherence of the gravel to the asphalt. And what you end up with is a newly overlaid road to extend the life cycle of this roadway. The problem with this is it ends up resulting in loose aggregate as it's newly placed. And what does that loose aggregate do? It creates a reduction in friction. A lot of loose gravel will greatly reduce the friction value, and this can be experienced by motorcyclists, and especially in curves as you increase the amount of friction available or needed to safely negotiate a curve as you're going through with a motorcycle. Reducing that level of friction can lead to a loss of control of the motorcycle and sliding out of the tires. This can lead to loss of control crashes, as I stated. Flying rocks and debris as they're getting kicked up from this process. I've had cases involving where motorcyclists typically move out of the way to avoid getting hit by these and put themselves into another condition or crossing another hazard that maybe they didn't need to move for. And overlays like this necessarily obliterate the existing roadway markings. So as you see in the picture to the right, there's no center line, there's no edge lines. And motorists are basically left to negotiate this roadway without the guidance of pavement markings that would typically be there. Case issues that we get involved with, again, involve inadequate temporary traffic control. As a motorcyclist myself, I would be looking for signs to maybe avoid this roadway. Motorcyclists need to be prepared that they are going to be in a section that maybe has reduced friction and recognize that they may need to reduce their speed or take the turn more carefully or avoid the area altogether. We see issues with improper pavement markings or failing to provide notice that there are no pavement markings through the area. Incidents of application rates, basically construction issues where either not enough aggregate or not enough asphalt or too much aggregate is being placed. And in both conditions leads to a condition where you have more loose gravel than would typically be expected for an overlay project. And then lastly, we see failure with contractors to sufficiently sweep the area of loose gravel as it's curing after they place it. And this leads again to an excess amount of aggregate that reduces the friction and creates a hazardous condition for motorcyclists. So what is the standard care for a chip seal project? It is to identify the application rates for both the asphalt and the aggregate, make sure that the aggregate and asphalt are being placed in their appropriate ratios or quantities, that it's being rolled properly, allowed to cure properly, that the roadway is swept properly. Then you open it up at the appropriate time for traffic. Opening it up too early could lead to excess aggregate being dislodged, which again adds to the condition of loose gravel that exceeds the amount that would be expected. The temporary traffic control that we see for this hazard are loose gravel signs. Again, these signs that are identified in the manual for uniform traffic control devices or the MUTCD are all very specific warnings to give motorists specific notice of the hazard that they're going to be facing, whether it's a bump, whether it's uneven lanes, whether it's loose gravel at this time. We see municipalities and states using a fresh oil and chip signs. Again, another specific warning of the hazard that is up ahead, and these signs then should be repeated throughout the length of the hazard as long as that condition exists to keep reinforcing the message that this is a hazardous scenario. Signs indicating that there are no pavement markings for a certain area are also temporary traffic control measures that we see to be employed, as well as the use of temporary pavement markings, depending on the duration, depending on the project itself. This may it may warrant the application of temporary pavement markings until the permanent pavement markings can be applied. And I believe the last hazard that I'm going to discuss here is milling. And milling is the process by which a big grinding wheel with metal teeth spins around and basically chews up a predetermined level or thickness of asphalt, puts it onto a conveyor belt, dumps it into awaiting trucks, and gets hauled off the project. What this does to a roadway, again, depending on the teeth pattern and the type of milling that's being done, but could leave significant grooves in the roadway or patterns of grooves. It can leave behind loose material because really it's grinding up and just chopping up this asphalt. It can create a vertical edge. As we talked, that whole longitudinal vertical edge, one of the most severe conditions is an edge created by milling, where you have a very sharp edge created by cutting asphalt. And what this also can do is expose areas of failed pavement underneath the surface. And these areas of failed pavement can lead to potholes and other, which is another hazard in and of itself that could be developed and exposed through the milling process. So the hazards of a milled roadway are, if these grooves are extensive enough, it actually can lead to a loss of control and have a significant effect on the handling of motorcycles. Anybody riding over a grooved surface or milled surface on a motorcycle can feel like it's taking control of the steering, grabbing the front wheel, forcing the rider into a direction that he may not want to go to. If you end up having loose material left behind or excess loose material, it could lead to a loss of friction of that roadway, which gets back to the prior hazards of loose gravel. Loose gravel, less friction, could lead to a loss of control, especially for motorcyclists who are more vulnerable to that condition. Potholes we talked about, and again, lack of lane markings. If there's not proper guidance and with lane markings, traveling public needs to be, one, advised of that, and two, ensure that there is positive direction provided through other means of temporary traffic control. Issues that we see regarding milling are failure to properly vacuum up or sweep up the loose debris, which then leads to a loss of friction and the other hazards that we talked about. Improper temporary traffic control. Again, motorists are exposed to a milled condition of a roadway without having been properly warned in advance that they're coming through this condition, as well as not continually being reminded of this condition as for extended areas of milled roadways. You see missing temporary pavement roadway markings, leading to issues. Leaving a milled surface in place for too long. Many contracts, many specifications require or restrict the amount of time that a milled surface can be exposed without covering it up with a new layer of asphalt. And basically that violating that standard unnecessarily exposes motorists to the hazards of a milled surface longer than maybe it should be. And then we see a failure of addressing any potholes or unsound pavement that is revealed or uncovered with the milling process. And again, each of those potholes and unsound pavement have hazardous in their own respect. So what is the standard of care for milling? Again, proper warning. As you see on the left there, a motorcycle placard, the W8-15P, is a sign to specifically identify and get the attention of motorcyclists that, hey, this is an issue for you. This is a hazardous condition. It's coming up. Be ready for it. Take an alternate route. Just be prepared for this condition. The cleanup is essential, making sure that these areas are properly swept for all the loose debris that's created during the mill process. And the maximum depth of milling can be an issue. If you're allowed an inch vertical height differential and you're milling at 2 inches, well, you've exceeded the milling depth, which then created an unreasonably dangerous condition of an edge that exceeded the maximum height of the longitudinal edge. The typical traffic control we see for this, as I talked about, are grooved pavement signs or milled roadway signs with motorcycle placards. These placards, as I said, highlight to motorcyclists that you are coming up to a condition that you are significantly affected by. And then temporary roadway markings. It's a little bit easier to apply temporary markings to a milled surface, whether it's through temporary paint or temporary tape. Excuse me. A little more difficult in the loose gravel areas to provide make that paint, but for a milled surface, that is an easy practice to do. So the questions that I'm asked when looking at these cases involve question of, was the temporary traffic control adequate that was in place? Did it give proper warning? Did it give proper advance warning or adequate warning? And was it presented throughout the work zone? Was the roadway that was open to traffic considered, was it appropriately open to traffic? Would it be a hazard that would exceed the specifications and maybe shouldn't have been open to traffic? Was the work itself completed in accordance with the contract and the applicable standards and standards of care for the jurisdiction that was governing the work? Was the traffic control reasonable for the work being completed? In other words, did they close 3 lanes of a 5-lane roadway when they only needed to close 2? In other words, unnecessarily creating a condition that exposed more motorists to a hazard than maybe otherwise should have been. Was there proper oversight and inspection of the work that was being performed? Were there obvious violations of the standards that maybe should have been identified or addressed by an inspector and corrected before the condition lasted too long? And then ultimately, we are asked to evaluate if any of these violations that we see somehow were causative to this incident. So the takeaways I'd like to have you walk away from this is that roadway construction may result in the creation of temporary hazards, temporary roadway defects. And these defects, by their very nature, are hazardous to motorcyclists, but they can be reasonably mitigated. Contractors, as well as owners, through the oversight of inspectors on site, can mitigate the hazards by ensuring that they have proper temporary traffic control and that the hazards themselves are meeting the applicable standards and required mitigation measures. A failure to properly mitigate these hazards can create an unreasonably dangerous condition, which may then be a direct cause to an incident. And I think, as Ann alluded to, here's my contact information, and any follow-up questions could be directed to me or Robson at inquiries@robsonfresco.com.
Thank you, Kevin.
You're welcome.
We do have a couple questions. First, to start, I mean, you are a motorcyclist yourself, so what goes through your head, and how do you manage when you're approaching defects like the ones that you've been talking about?
Well, I think primarily I try to avoid them when possible, especially the tar and chip, the oil and seal projects. If I see one of those signs in advance, I will do everything in my power to try to avoid going down that road, not only from a safety hazard, but from an aesthetics. I don't want these rocks pinging off my vehicle, so I will try to avoid them. Really, the key is advance warning and being able to prepare myself. If I'm going down a highway and I see a milled condition ahead, I may put myself in a lane that's not milled and try to put myself there before I have to cross one of these vertical longitudinal edges. So again, to me, the advance warning is critical and advanced in early enough that I actually have time to react and to register to what I'm coming up with and make a decision on how best to traverse through that work zone. Right.
So advance warning is key for sure. We have a question about uneven lanes. If all there is to determine how uneven the lanes were is photographs, can you work with that?
I would say most of the cases we get, that is all we have.
Okay.
There are several ways that we can look to address that, from looking at the plans, what was required on the plans, to it does make it a little more challenging, but I would say most of the time we don't have a proper measurement of the specific height differential that was in place at the time. So actually, one of the recommendations is that if there is an investigation to these incidents, that condition is measured as quickly as possible. But unfortunately, that condition is very short-lived, typically a day, less than a day. But routinely, we don't have that specific measurement when we get involved in these cases.
Okay, fair enough. I think that sums it up in terms of questions. If anyone has any lingering questions or you want to connect specifically about a case, again, our contact info is up here, and you can always submit a web inquiry if you go to robsonforensic.com/contact. It'll give you that form. Otherwise, thank you, Kevin, and thank you everybody for joining us today.
Thank you, everybody.
We'll catch you on the next one.